Yes, so we have determined that we are doing this problem number 5, and then we have determined that the planned value is 7,200, which is the same as the earned value as it has been given in the statement of the problem. The actual cost is $9,000. Actual expenses are $9,000. $9,000. So what we have to find is so we have to find it what are the cost and schedule variances. So the cost variance is 7,200 minus 9,000, which is equal to minus 1,800. Okay, so in dollars, so I'm not putting the dollar value over dollar symbol over here. Schedule variance is 0. 7,200 minus 7,200 is 0. What else we have to find? We have to find the three indices. Okay, three indices. Cost performance index will be 7,200 divided by 9,000. So it is 0.8. Schedule performance index is 7,200 will be 1, and the cost schedule index is will be equal to cost performance index times schedule performance index. It will be also equal to 0.8. So what we have to find over next, we have to find is estimate to complete and estimate at completion. So estimate to complete means that means what is the remaining cost to complete. Okay, estimate to complete and estimate at completion. So first we can find the estimate at completion. So estimate at completion will be equal to the most useful formula, which is equal to budget at completion divided by the cost performance index. Okay, divided by the cost performance index. But what is budget at completion? Budget at completion is the total planned cost for the whole project. Okay, total planned. So total planned cost is the sum of all of these costs of these activities. So this project has these activities from A to G. So what is the total of this? So the total of this we need to for this we need to calculate. We need to add up all these. So when we add the cost of all these activities, so the value is 8,800. 8,800. So the estimate at completion is equal to 8,800 divided by the cost performance index. Cost performance index, it is 0.8. So if I divide it with this 0.8, so it is 11,000. So in terms of dollars, 11,000. So it simply means that the project which was initially planned to be completed in $8,800 will now expected to complete in $11,000. So from this is the estimated cost at completion. So from this we can find the estimated cost to complete. So which is the difference of this estimate at completion and the actual cost to date. Actual cost to date is $9,000. So $11,000 minus $9,000. So estimate to complete will be $2,000. So in this way you can find it. Well, there are some other formulas for calculation of EAC and ETC, but those formulas will also result into the same values. I use these formulas because it is, for me, it is easy to remember. So you just take the budget at completion divided by the cost performance index, and similarly for the estimate to complete, you have to just subtract actual cost from the estimated completion. Yeah, one more thing which I want to point out here is that the estimated completion formula over here assumes that the same situation will continue in the future as well. Okay, so based on this assumption, we use this formula, and this is the most common formula which is used. There are other situations as well, but we are not looking into those situations for the calculation of estimated completion. Perform the earned value calculations for the following project data. Use the 0 to 10%, 0 to 100% rule for earned values. So this is problem number 6. Okay, so the data is given for this project, and the status date is 7th day. Okay, so we can determine its network. Okay, so activity A, activity A activity A then B and C, C, and then D, and then E, yes, E. Okay, so this is the small project, so therefore this is the end of the project. A is 3 days, B is 2 days, C is 5 days, D is 4 days, and E is 2 days. So calculate the activity times. Zero 3, so this will be 3 and 8, and then this will be 8 and 10. So therefore ACE is a critical path. So we have this schedule. So what we can do is I can draw a Gantt chart, kind of Gantt chart for each activity A, B, C, D, E. Okay, so here if I will draw A, B, C, D, E, and then I will show the number of days, 3, 2, 5, 4, 2, and then the budget. Okay, so the budget is 600, 300, 800, 400, and 400. So the number of days are like 1, 2, Okay, so this is the end of wave 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so the activity A is from 0 to 3 days. So, but we are activity A is from 0 to 6 days, 0 to 6 days. Okay, so this means that 0 to 3 days activity A is from for the first 3 days. So 600 we can distribute it as 200 for these 3 days. Activity B is from 3 to 5, so from here to here for 2 days. Okay, that means from 4 to 5, so it is 300, so it will be 150. C is from 3 to 8, that means from here to 5 days. And then for 5 days, yeah, so 5 days, so 800 divided by 5 is how much? 100, and 800 divided by 5 is 160. Okay, 160, 160, 160, 160, 160. Okay, and then D is from 6, 7, and 8, 9. 6, 7, 8, 9. So D is from here. For 4 days, 100, 100, 100, 100. And then E is for 2 days from here. So 200, 200. Now I can add up all these values here. For each days. So for the first day it is 200, 200 again, 200 again. So this is 150 plus 160, it is 310, 310. This is 260. This is 260. This is also 260. This is 100 plus 200 is 300. And then this is 200. Okay. So what is the planned value? Okay. Planned value, today is the date 7, so day 7, 1, 2, 3, 4, 5, 6. So at day 7 over here, so for the first 6 days, okay, so for the first 6 days, what is the total planned value? So planned value is, well, for A is 600. A has been completely planned within these 6 days. B also completely planned plus 300. C is planned like 160, 160, 160. It is 480. D is planned as like 100. And then E is not yet any cost, so it will be. So planned value will be total 900. Then it will be $1,480. $1,480 planned value. Okay, so it is. This is almost the end of this video clip. So I will continue this problem in the next video clip.